There are only 11 students today. Yeah. Hello. Hello, Madhvendra. Can you hear me?
Yes,
Yes,
sir.
sir.
Yeah. Only students are joining, or only 11 students I can see.
I don't know, sir, because in last lecture also there were less students from product.
Okay. Again, today there is a lecture at 1:30. Okay, I'll wait for 1 or 2 minutes more. So we are doing programming, CNC programming. Dimple is there. Renan, you have installed NX, no? That is student edition.
Yeah, student edition.
So is it expired?
Yeah,
Did
it
you
got
check? Expired, no? I think they had validity till 30th of September. The student edition, but now the new edition is available. So which you can try if you wish, and that will be available again till July end 2021. You can check. Hmm? So again, same procedure.
which version is it?
Download and sorry,
Which
that
uh,
version I don't remember. I'll check it and I'll post it. Huh?
okay, sir.
But whatever you have submitted, that is there in the Google Drive, so you don't have to worry. Hmm? From the submission point of view. Okay. So this programming part is important from your examination point of view. Is this visible? Hello? Is the screen visible?
Yes, sir.
Hello? Yeah.
Yes, sir.
You can see the program number, etc. Okay, so now you are familiar with this. Now, the why I ensure, otherwise I will keep on talking and nothing is visible. So G codes, you know these, they are called as the preparative functions. M codes are called as the miscellaneous codes. So this is one difference. Another difference is there can be multiple G codes in a block, whereas only one M code is allowed in a block. Then model and non-model. Not, so model remains active. Non-model is active only for a particular block. So now this is how to read this. This is G00. So it is not GOO. So G00 stands for rapid positioning. That is, the movement will happen in rapid. Rapid means at the rate of 10 meters per minute or at the rate of 15 meters per minute. That is what we are talking about rapid positioning. So that is G00. How to read it? G00. See, 0 means it is oval, and if it is O, then it is round. O is a round or a circle. I say. Today the peoples are very less. I don't know why. Hmm. Then you have G00 is a model. Means what? It remains effective till it is replaced by G01 or G02 or G03. And on the graphics, that is on the simulation, this Z00 will appear as a dotted line. When you simulate on the screen, there is a toolpath simulation facility. So it will be shown as a dotted line. Some people, some control, they use some colors, different colors, maybe red color for the fast movement and maybe green color for the slow movement, that is for the feed movement, just to have better visibility. So now this is an example. Assume that the tool is positioned at point 1. I hope it is seen, or I will zoom it. बड़ा करता हूँ. Hmm? Okay, so this is an example of Z00. So tool is positioned at say point 1. Alright. And this point 1 is with respect to, now this is what is your program 0 point. Again and again I am telling that you have to show program 0 point, and this is the symbol on the drawing for the program 0 point. Hmm? So with respect to this, what is the coordinate of this? In x direction 15 and in y direction minus 20. So this is 15 minus 20. Alright. Now this is simple hole to be drilled. Hole is to be drilled here. So from here to here, there is no machining. Machining is only at this point and at this point. That is drilling happening. So this is the idle movement. So this should happen fast. So that's why we use G00. So G00. Now next point is X75. That is 60 plus 15. This is with respect to this point. And then Y minus 20. So this is rapid movement. And again, then you will use feed movement. That is G01. G01. So this was rapid positioning. Now this is G01 means it is linear interpolation. Linear interpolation. So linear interpolation means it is actually some machining is going on. Some machining is going on. So that cannot be done at very high feed rates. Very high feed rates cannot be done. So we use G01. So again G01 is a model. Model means it remains effective unless and it is changed by other codes like G00, G02, G03. And then on the screen, on the graphic screen of the CNC machine, it appears as a continuous line. So this is a typical example of say G01. See, now from here to here we have to move. Now, uh, so what you have to give G01, okay, then X75, Y minus 20, F20. That means some machining is going to happen here. Some machining, maybe now milling. So the cutter will cut when it moves hmm, in this direction. And you must give feed. If it is G01, then you need to give feed rate F20. So feed rate can be either in millimeter per minute or it can be in millimeter per revolution. It can be in millimeter per minute or it can be in millimeter per revolution feed rates. And remember when you are using um, when you are using G01, you have to start the spindle first, because when you are giving feed rate is millimeter per revolution. So the control must understand what are the revolutions, isn't it? What are the revolutions? So you have to rotate the spindle so that the control understand now, yes, spindle is rotating at some 900 RPM, revolutions per minute. If you don't rotate the spindle, then it will give the error that there is an error that spindle is not rotated. Spindle is not rotating. So before using G01, two things. In G01, you have to use feed and you must switch on the spindle. Your spindle must rotate. You have now G02 and G03. So G02 both are circular interpolation. One is your clockwise, that is G02 means it is clockwise interpolation, and G03 is your anti-clockwise. It is also called as the CCW, that is counterclockwise. Then you have to give the feed in G02 or G03. You must give the feed rates. And the syntax G02 and G03 ka syntax is you have to give the start point, you have to give the end points, and you have to give the radius of the arc, or you have to give the center point, circle ka center point. Otherwise, the control will not understand how to cut. So this, that is, you have to give the start point, you have to give the end point, and you have to give where the center point is. Or you can give the radius also. So that is also sufficient. Either radius or give the center point. Giving radius is convenient. Giving radius is convenient. Now this is here, it is moving like this. That is clockwise. So obviously you will use G02, and here it is counterclockwise. So here you will use 3. So it will be G03 here, counterclockwise. So in this case, this is your start point, this is your end point. In this case, this is the start point and this is your end point. So this is the example of G02. So whenever in the examination, no, in the unit test, like if they ask, if it is asked that give an example or explain G02, then you have to, this is the answer. This, like you have to draw a sketch, you have to say that G02 is nothing but two mass killing. G02 is nothing but clockwise interpolation. Then you have to give an example. This is your 0 point, program 0 point. This is your start point and end point. So initially the tool is here X40 and Y40. Alright, then G02, you have to give the end point. So end point is X80, Y80, and radius is 40. If it is G03, then this is the example. That is, the tool is at this point, X80, and then it moves in this direction, G03, where end point is X40, Y40, and R40. So now this is by default, it is all in G90, remember. By default, it is in G90, that is absolute. This is in absolute, remember. If you are using G91, then it will become little complicated. Like suppose here, say first example. In first case, suppose if I use G91, then like here now, if I want to use G91, so I am here G01, X40, Y40, and now I will write here G91. So G91 means how much it will come? The next point is it is incremental distance. So instead of X80, it will be now 40 because this distance is 40. This distance is again 40. So it will be X40, G02, G91, X40, Y40. And radius will be absolute value. So that will be R40. If I want to give the center instead of R40, then I can give center here in I and J format. IJ. ij. So now I will tell you how to give the center I. I means x direction and j means y direction. So here I with respect to this in x direction it is 40 on positive side. So it will be I 40 and j is nothing but center in y direction. So that is 0, isn't it? Because the center lies here. It is always the incremental I and j. And if it is in z direction then you have to use k. So ijk is slightly difficult. So that's why most of the control they have this facility that you can define the arc by radius. So this is very simple. So this is what I was telling that you have to give the if you have to specify it by center point, then you have to give I, then you have to give j, and you have to give k. So what is I? It is nothing but the distance between the start point. It is always incremental, whether you use G90 or G91. This ijk is always incremental. The format is like that. Distance between start point of the cutter to the center of arc in x direction. J is nothing but distance between start point to the center of arc in y direction, and K is in z direction. IJK. So that's a helical interpolation. If you are using IJK. Hmm. See, this is what I was saying. The values of I, J, and K are always incremental. So even if you give G90, you have to give centers in incremental style only. Remember. Why it is not moving, and just a minute, something wrong. Is it visible, Madhav? Screen? I think it is not visible, no?
No, not visible.
Ah, now it is visible, no?
Yes, sir.
Hello? Yeah.
Yes.
So this was I was telling about I, J, and K. These values are always incremental. Hmm. So this is called as the interpolation. इसको हम लोग interpolation बोलते हैं. This is what is your interpolation. So if you say I already told you like x80, y80, so you are giving endpoints here, and if it is in center point format, then I will be 40 and j will be 0. Incremental distance will be 0. Now G04 is nothing but your dwell. So now again you have different format for your dwell. So dwell means only the spindle will run and the axis movement will stop. axis movement will stop. Now, what is the purpose of dwell? What is the purpose of dwell? Like suppose now you are doing reaming. So reamer comes down, okay, slowly, and at the bottom of the hole, what we do generally, we stop the feed movement of the reamer. We only, keep on rotating the reamer for a while, maybe 5 seconds, 10 seconds, 15 seconds, so that you still get a good finish. So this is what is your dwell is. Means your cutter is rotating, but the axis movement is stopped. It is something like, I have given example, like suppose you have done a shaving, okay, and then last cut, you just move the razor, 2 times, 3 times, just to get a good finish. So that's the idle movement, but it improves the finish. So now here, what is the syntax? G04X2 means it will have a dwell of 2 seconds. Mean your reamer will keep on rotating for 2 seconds without any axial movement. There will not be any axial movement. Whether it is X, Y, Z, it will stop. Again, different controls will have different styles or different syntax. Like X2, this is in Siemens, means it will pause for 2 seconds. Had it been Fanuc, then if I want to give 2 seconds, then I need to write, first thing is that I need to use letter P, and then if I want to have a dwell of 2 seconds, then I must write 2000 divided by 1000. Remember always in Fanuc. So 2000 divided by 1000. So that will be taken as 2 seconds. So in case of Fanuc, it will be P 2000. If I want to dwell for 5 seconds, then it will be P 5000. In case of Siemens, it will be simply X5. So now these G04 students, they always, give wrong answer in Viva. So now this is not your X2 means it is not your X-axis movement. I am telling you again and again. And that's why in Fanuc that is taken care of, because this usually sometimes the people get confused. अरे X2 मतलब X direction में 2 मिलीमीटर आगे जाएगा, but no, see it is associated with G04. G04 means मतलब dwell है. G04 का मतलब dwell है. At X2, so you will ask why not Y, why not Z, but they have programmed like this. The syntax is like this. So here G04 X2 means it doesn't mean that the machine will move by 2 millimeter in X direction. Since it is with G04, the machine will stop for 2 seconds. Whereas in Fanuc it is P2000. And P is not associated with any of the axis. So people are comfortable in Fanuc. So again, this is active only for that particular block G04. That means it is non-model. So in the next block, it will not remain active. If you want to use dwell again in the next block, then again you have to write G04. Otherwise, by default, it will take, if you are not writing, then it will take it as G00, rapid movement. Then cutter radius compensation. This is very, very important and very frequently asked in the question. So cutter radius compensation is nothing but whatever diameter, tool diameters what we are taking, that machine should understand what diameter we are using, what tool diameter we are using. That machine should understand. That is what is called as the cutter diameter compensation, or it is also called as the cutter radius compensation. So this is what you should write down. Uh, I'll go a bit slow and let me see. So you need to draw this diagram. Very important. That is cutter radius compensation. There are two types of cutter radius compensation: G41 and G42. Hmm, G41 and G42. So please draw this diagram. There is a difference in the direction. And you need to draw one more diagram. Now, this is the circular hole which is to be machined. You need to draw one more diagram. There this is a pocket, a circular pocket which is to be machined. Now you draw one more diagram showing a rectangular pocket, and you also draw in that rectangular pocket. You draw a cutter. Two diagrams. So altogether four diagrams you need to draw.
हॅलो हा 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 बोला हा हा ते करायचंय ना गुरु नाही हो बापरे हो हा आता काय करू थँक्यू हा करायचंय ना पण हा हो चालेल मी मस्त पाठवते हा.
So I hope you have drawn these diagrams. Four diagram. That is, this is a circular pocket in which now cutter is moving. Now this is cutter radius combination G41 and G42. When you say G41, it is cutter is on the left hand side, and when you say G42, the cutter is on the right hand side. Now what do you mean by left hand side and right hand side? Now look here, this is the pocket, circular pocket, which is to be machined. Now if you want to swim in this direction, or if you are walking in this direction, how you are walking? You are walking on the left hand side. of the arc, isn't it? You are walking on the left hand side, so that's why it is called as the G41 or on the cutter compensation on left hand side. Now look here. Now you walk in this direction. You walk in this direction. So where is your border? Trajectory is this. So if you are walking or if you are swimming in this direction, it is on the right hand side. So that's why you have to use your G42. That is on the RHS. Now why this cutter compensation is required? Because by default, all program, whatever you are writing, that is always with respect to the center line, spindle center line, spindle center line. So it is like this, spindle. Like whenever you say G02, G03, so it is always with respect to this center line. Or if it is a rectangle, like say this is the rectangle what you have to machine. Suppose. Hmm? Then what you are giving in the program, that is this border. That means if your cutter diameter is 0, then only you will get this. But how it is practical? It is not possible, isn't it? How you can machine with a cutter having 0 diameter? The cutter will always have a diameter. So now this is center line programming, and if I want to do this block, block machining means what? I am not doing say cavity. Block machining means I am doing external cutting. So my milling cutter has to be here. If I am doing milling, so it has to be here. It should be like, suppose if I am going like this in direction, in this direction, so it will go like this, aisa, milling machine. So if it is say 10 dia, if the cutter diameter is 10, if the cutter diameter is 10, then it has to offset the center line of the end mill will be offset by 5 mm, isn't it? If the cutter diameter is 0, then center line of the cutter will be exactly over here. If the cutter diameter is 20, then the center line will offset by 10 mm. Understand? So accordingly, I have to position. So this is very important, G41 and G42, which will allow you to uh, use the same program with different diameter, because it is not possible every time. Like now, suppose if you are using same diameter 10 cutter, uh, then you need to write the program. If you are not using G41 and G42, you need to write the program which will correspond to the center line of the cutter, considering that 5 mm offset. The diameter of the cutter is suppose 10 mm, then you need to write program considering 5 mm offset. Now what happens, suppose in the store, suppose 10 dia cutter is not available. He says, sir, 20 dia ka cutter hai. Then again you have to change the program. Then you have to offset by 10 dia. 20 dia ke liye you have to offset by 10 millimeter. So again you have to rewrite that program by offsetting the distance by 10. And what will happen, suppose if the cutter is ground and if the diameter is 19.98 or 16.48 divided by 2, so that will be very complex. So that's why you have to use this cutter radius compensation or cutter diameter compensation. So G41, G42 allows you to use the various diameter cutters. And of course, you have something called as the offset, tool offset library in the control. Then you have to go to that tool offset page, and there you have to key in, or there you have to write the diameter of the cutter or the radius of the cutter depending upon the control whichever you are using, and that tool number you have to write it in the program. So moment you write say tool number 1 or tool number 2, the control will look for the, or control will take the data from the tool offset page. It will read the data corresponding to the 2 T01. So T01 mein diameter is say 10. So the control will offset the center line by 5 mm. So there are two things. One thing is that you have to mention the diameter in the tool offset, and you have to write that tool number in the program. By writing it in the program, you are linking that program command with the tool number. If you don't write that tool number, or if you don't write that offset number, then program will not understand, machine will not understand what is the diameter unless and until you write T01, or in some control it is D01, D01, that is for the offset diameter. So this writing is in the program is very important, other than your G41 and G42. So you have to understand two things, that you have to write whether it is G41 or G42, and you have to write which tool you are using, and you can fool the machine. You can fool the machine. How to fool the machine? That is, you have written T01 in the program, and actually you are using, say, you have put the tool of, say, 10 dia, or let us say 20 dia. The actual tool diameter is, say, 20 dia. Hmm? That means here the tool will be offset by 10 millimeter. Tool will be offset by 10 millimeter. But how to fool the machine? That instead of now 20 dia, which you are going to write in tool offset, you write 40. Machine or control is not actually physically going to measure the diameter. It will go as per whatever dimension you have written in the tool offset page. So you have written 40, but actual diameter is 20. How much will be offset? How much machine will offset? It will offset by 20, because the diameter is 40, so it will offset by 20. So this size, this size, how much you will get? You will get extra, isn't it? You will get more. You will not get the design. Are you understanding? Like, suppose if I want this as 100, if I am using the correct diameter, like say 20 dia, and if I write in the tool offset 20, I will get 100 exact. But now my cutter diameter is 20, but I have written 40. So what will happen? 10 mm this side, 10 mm this side. So I will get this size as 120 instead of 100. So what is the benefit of this? Same program and same tool. I can use it for roughing. I can use it for semi-finishing. I can use it for finishing. I hope you understood. Means what? You have to just play with the cutter diameter. So instead of now 20, you give, say, 21. So the moment you are giving 21, that means what will happen? You will get extra zero point 0.5 per side of the component. I hope you are understanding. So this is the beauty of this tool offset page and G41, G42. So G41 is nothing but compensation applied uh, on the left, when G42 is compensation applied on the right, and you need to cancel this. So you have to use G40. And as I said, how to use G41, G42, that you have to swim along with the direction, along with the path. Advantages, I told you that different diameter of the cutters can be used. And you cannot imagine without this, cutter compensation, it will be very hectic. And that is, you will have to always, add, subtract the diameter if you are not using G41 and G42. Generally, this is, if you don't want to use G41, G42, then the programs are generated using software, CAD/CAM software. So there, mm, it is done very fast. So there, what happens? You just key in the diameter, and you will get the program as per the diameter keyed in. So the control will calculate it very fast, and it will give you the program. So what happens whenever the program is generated through the software. So there the programmer every time writes the diameter, okay, and he gets fresh XYZ points, fresh XYZ points always. So he'll get different programs. Like suppose now he has put 20, you will get one output as per the dia 20. Instead of 20, suppose if it is 19.68, then he will write 19.68. Again, all XYZ points will change because now the computer is calculating. We are not doing any manually calculations. So he'll get a fresh output, and that fresh program here he has to key into the control. Hmm. But instead of this, G41 and G42 is always same. Only you have to take care that you use properly G41. That is, instead of G41, that is, you you want to move like this, and if you do G42, if you are using G42, like you are going to move like this G41, and if by mistake suppose if you use G42, so G42 का मतलब क्या? It will be on the right hand side. So instead of moving cutter like this, and this is little tricky, the cutter will move like this now. ऐसा move. Understand? So if you want a circular hole of 50 interpolation, you will get a larger hole. I hope you are understanding. Here suppose now here it is G42. Okay. Now suppose if G42 means it is on the right hand side. So if you use G41, so G41 matlab this cutter will be on the left hand side. That is this. So again, you will get a larger hole size. So here you have to be very careful when you are using G41, G42. But that is not so difficult. It is simple. Hmm. Then the next important code is G70. That is inch. Suppose if we have inch drawing, then you can use G70. So now G70X4 means you don't have to write this symbol. So since you have written G70, it will move by 4 inch. There are two more codes which you need to remember. One is your G94 and another is your G95. So G94 means it is millimeter per revolution, and sorry, G94 is nothing but millimeter per minute, and G95 is nothing but millimeter per revolution. And if you are using G70, so obviously G95 will become inch per revolution and G94 will become inch per minute. Again, this is a model code. This G70 means model code. So it remains effective throughout the program. Most of the time we use G95 because our feed, and G71. G71 is for millimeter. So now here it is G71, and if you are using G95 f.02, it is considered as millimeter per revolution. If you use G94, then it will be feeded in millimeter per minute. And obviously it is quite logical that if I am using 100, so 100 it cannot be 100 millimeter per revolution. It will be too fast. Here again you have to be careful here, because now instead of G94, suppose if we use G95, then accident will happen. If we use G95, because it will take it as millimeter per revolution. It will take it as millimeter per revolution. So you have to be careful. So if you use G95, it will be 100 millimeter per revolution. Remember, and if your spindle is running at say 2000 RPM, so what will be the feed rate? Can you imagine 2000 into 100? 2000 into 100, that is 20 meters per minute. At such a rate, it's going to cut. So obviously, it's going to cause accident. Cutter will break or workpiece will fly off. Something will happen. So G94, remember, millimeter per minute. G95 millimeter per revolution. So moment it is G95, see that this F is in the range of zero point 0.1, zero point 0.2, zero point 0.3 like that, not more than 0.3. Alright. So G94 is your millimeter per minute. G95 is your millimeter per revolution. Remember. There is a, you have to remember this G94 millimeter per minute, G95 millimeter per revolution. Then there are M codes, which are called as the miscellaneous codes. So which performs the miscellaneous functions. And before that, I will give you some, list of the codes which you can quickly write it down. Let me see. So it will be easier for you as well as for me also to teach. Yeah. So you please write down this quickly.
Hello?
These codes you please write down quickly, or just go through this, or you can take a photo, whatever it is.
तो हो जाएगा वो हाँ 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 चालेल हाँ हाँ म्हणजे काय पेंडिंग हाँ ते किती अमाऊंट असेल आता आता चार हाँ हाँ तेच बोलते म्हणजे 50 जर असेल ना तर अर्धा तासाच्या आत होतं अर्धा अर्धा तास लागतो नाही काय 49 असेल ना हाँ हाँ मग नाही मग नाही 24 तास मग 24 तास हो ऍड करून दे चालेल लाईट हा मग लवकर ते ऍड करायचं हा हा मग मिरर देत आहे ना मला हा जे